So for this lecture, we're going to go a little bit more quick and dirty here. We're using this mini whiteboard. Also in the background, my daughter is practicing her part of Dorothy. So she's practicing lines, so you may be picking that up as well. What we're going to talk about mainly here is our chapter on experiments in our textbook, and focusing on the first portion here. So we're looking at experiments. And in particular, we're going to be thinking through what can go wrong. Because if experiments go right, then they are the gold standard in figuring out the effect of a treatment. So if you remember way back in the beginning of the semester, we talked about what had to be true in terms of a treatment group versus a control group. And we had our potential outcome. Right, we had the outcome for an individual I who received the treatment and the state of the world that he received the treatment. This is saying that the individual is in that treatment group. And what we needed to know in order to capture the true treatment effect was the counterfactual. So the outcome in the state of the world that he did not receive the treatment for the group that was treated. So this is, even at home, markers still aren't working. This is the counterfactual. And it's unobservable, but with an experiment where the treatment itself is randomly assigned, we would expect that this counterfactual is going to be well approximated by random assignment. So we're writing that the treatment equals 0, meaning that the group of people who are not receiving the treatment. So these are different sets of people. So this is unobservable, it's the counterfactual. This is observable. These match. If we have true random assignment, then these should be equal. There's no expectation of difference. But what we're going to talk about in this series of lecture is what happens when experiments don't quite reach that ideal for one reason or the other. We're going to talk about the ABCs of what can go wrong in experiments. We're going to talk about attrition, we're going to talk about balance, and we're going to talk about compliance. And we're actually going to start and do this in backwards order. We're going to start with compliance because that is the focus of our lab, and it ties really well into instrument variables. So compliance. The idea of compliance is when you're assigned to a treatment and control group, do you actually get treated when you're supposed to be in the treatment group and not get treated when you're supposed to be in the control group? Do you comply with your assignment? So the way we're going to illustrate this is we're going to start off with a tree diagram here if my my whiteboard will hold up. And in fact, this whiteboard is balanced on my kid's old high chair, making it work here at home. So we're going to start off with random assignment. So we're going to assume that the assignment into the treatment and control group is truly random, meaning that there's no endogeneity problems here, that because it's random, it is independent of the error term. Alright, so everybody is either in the treatment group or in the control group. Now, I think it's worth it to motivate this using our same example that we're using in lab. That's the example of people being targeted with a campaign where poll workers are going to go, knock on their doors, talk to these individuals, and try to convince them to vote for their preferred candidate. Now we're randomly going to choose some houses to talk to. However, whether or not we actually end up having those conversations is going to be the question. So this is random assigned into the treatment group. And this is assigned into the control group on this left-hand side here. However, because you're doing these knocking on doors, not everyone's going to answer the door. So just because you're put into the treatment group doesn't mean you're necessarily going to have a conversation. So what we're doing is we're actually considering our treatment in this example having a conversation. So some of the people in the treatment group will actually be treated, meaning they have the conversation. Other people will just not either be home or not answer the door. Those will be your non-treated. We're not going to spend as much time talking about it, but just because the same ideas apply across both nodes here. But for your control group, it's possible that some houses were put in the control group, but maybe you were talking to the house across the street, and the person called out to you from across the street, and you end up, your poll worker, your volunteer, ends up actually having a conversation. So even though they're in the control group, they are somehow treated. All right, so this is our tree that we're thinking about looking at potential outcomes. Now there's a worksheet that I'm going to send out that goes on with this lecture. And what I want you to calculate by hand are the averages for particular groups. So what I want you to calculate is the average vote for those who are treated. So here are the people that are treated. Right, there are two different types of people that were treated. There are people that are treated in the treatment group. There are people that were treated in the control group. And so I want you to calculate the average share that vote in each of these groups in that worksheet. And that is going to be your coefficient for regression, y equals beta 0 plus beta 1 treated. This is just normal, ordinary least squares. We're just saying, what's the effect of having a conversation? The problem is, if we estimate the effect of having a conversation this way, then we are ignoring any potential relationship between having that conversation, being treated, and other stuff that impacts the vote here. And you might think there could be an impact. Potentially people who are more likely to vote are also more eager to have a conversation. Old people stereotypically or statistically vote more, and old people are typically going to be home in a higher proportion than younger people for having those conversations. And that could potentially mean that you're, even though you're randomly assigning, the treatment itself is actually, there's some selection bias happening for the treated versus the non amongst your randomly assigned groups. So OLS might be biased in this case. I also want you to calculate the average vote share for the treatment versus non-treatment group. So ignoring whether or not they actually had the conversation, was there, what is the difference in the voting outcome with the treatment group and the control group? So you'll look at vote, beta 0 plus beta 1 assigned. So if you're assigned to one of these groups. Now we know, the nice thing about looking at it this way is we know we're randomly assigning. So there's no endogeneity problem here. So there's no issue with housing being assigned. Now if there is some sort of impact of having these conversations, and if being assigned to the treatment group is increasing the conversations, then we would hope to see that impact here. We should see that people who are assigned to the treatment group, if they are getting treated more, will vote more. This estimator has a particular name. Our goal in putting them in the treatment group was we are intending to treat them. So this estimate here is the impact of that intention. And so we term that estimate the intention to treat. Sorry, I'm not used to working with whiteboards that are this small. Intention to treat, or ITT. And the difference in averages, this is a binary variable. The assigned is a binary variable, so this beta 1, without any other covariates, is just going to be the difference in the average for assigned and the average for treated. I want you to, on your worksheet, calculate out the difference in the averages. So basically, this is the one and only time I'm having you calculate OLS coefficients by hand. It's just a simple average. Same thing here. The difference in the averages for treated versus norm. I'm going to stop there. What we're going to talk about next, in my next short lecture here, will be how we can use the assignment as an instrument for being treated, and how that gives us an estimate not of just the impact of being in the control group, but the estimate of being treated itself, the estimate of the causal impact of having that conversation. Thank you for your flexibility here as we use a lot of different techniques to have these lectures. Please follow up with questions, and I'll be posting the next lecture hopefully soon. I hope to interact with you, and I hope you all are doing well. Take care. Bye.